A first order reaction takes 40 minutes for 30% decomposition. Calculate T half. That is the question. Okay, so it's a first order reaction. T half you have to calculate. So how to do this question? So better I will do this thing since the very first question. Correct. So what is my T half basically? 0.693 by K. So this is a kind of 3-mark question which can be asked in the examination. Correct. And what is my K? Rate constant. How do I calculate K? Simple formula 2.303 by T log of R naught by R. Correct. So read the question very carefully. First order reaction takes 40 minutes for 30% decomposition. 30% decomposition in the sense, what is my R naught? The initial concentration, right? Initial concentration of reactants. Initial concentration. So initial concentration, if it is 100% or if it is 100, correct? What will be my R? After 30% decomposition, it will be what? I think everyone understood this thing. See, suppose if it is, this is the 100% thing, the graph thing, whatever I'm drawing here, no? Let me draw here. Yeah, if this is the 100% thing, correct? And if I want to draw 4 quadrants in this and divide, okay, correct. So the 30% is being decomposed. So remaining how much is there? Remaining out of 100, 70 is there, right? So similarly, R will be what? 70. So now we have to substitute both these equation, both the R naught and R value in this equation. So I'll be getting what? K value. So K is equal to 2.303 by what is my T? T is 40 minutes. So I'll directly write on 40. We need not convert anything until and unless they specify about seconds or something. Correct? Log of 100 by R naught is 100, 100 by 70. 10 by 7. So again, for simple calculation, what we can do? We can do what? Log 10 minus log 7. 2.303 by 40. This is my log 10 is 1 and log 7 value. So those things we have to know what are the values, which I already given you the log table for calculation. So once we do all of those calculations, we'll be getting the answer 8.918 into 10 power minus 3. Correct? Minute per minus 1. If it is second, second per minus 1. So once we get this K, what is our next step? We have to find what? T value 0.693 by K. T half is equal to 0.693 by, what is my K? 8.918 into 10 power minus 3. So this is equal to around 77.7 minutes respectively. Yeah. Is everyone done with this question? Let me know. Done. Okay, fine. Then let me take the next question and let's see how many of you will do this. So this will be the similar question, but on a higher level. Let's see how many of you can try this question. Yeah. I just now showed the screen sharing. Same kind of question for a first order reaction. Show that the time required for 99% completion is twice the time required for completion 90% of the reaction. In this question, it is show that. Same concept you are using. Okay, so if I want you to do this thing, I'll just help you out with this also. Correct. So basically what it is, we have to prove what? The T half of 99% is equal to what? 2 times the, what it is? For a first order reaction, show time required for 99% completion twice the time required for the completion of 90% of the reaction is twice. So you just prove T99% is equal to 2 times T90%. That's all. This is what you have to prove. T90%. Okay. So now for doing this thing, if I want to take the T general formula, 2.303 by what? K log of R naught by R. Correct? Just like in our last question, in this question, 99% completion meaning. 99% completion means what? In the sense, R naught, initial concentration is 100. So what is my R value? R value is 1. How I am getting it? 100 minus 99. That's it. Because out of 100, if 99% is completed, how much is remaining? 1 only is remaining. Correct? Yes. This is the first one. Second one is what? Second equation is, let me write with the other color. Yeah. 90% completion. Same thing. R naught here is 100. R is equal to what? 10. Because if 90% is completed, only there are remaining only 10% is there. Yes. Correct. So now I will substitute both these for 90% completion as well as for 99% completion. I'll substitute these values in what? This equation number 1. In the sense, for the first one, 99% completion, what I will be getting? I'll be getting T99. I'll write down here 2.303 by K. K, we don't know what is the value. Log of what is my R naught? 100. 100 by 1. Log 100 is what? 10 square. Correct? T99 is equal to 2.303 by K log 10 square. This is nothing but 2 log 10. Correct? So what is my log 10 value? Log 10 value is 1. That's it. So 2 into 1. So we have to just keep it as such. Now for 90% completion, similarly, I'll substitute in equation 1. So again here T is equal to 2.303 by K. This for T90. Log of 100 by 10. That is log 10. That is 1. Now what I have to prove? Always come to this. Correct? I just wanted to do T99 by T half. In the sense, T99 by T half. What is the ratio? Or T99 by T90. Correct? Yes. So if I want to do that, what I'll be getting? This is one answer is 2 log 10. That is this one. Correct? So I'll be getting the ratio of 2 by 1. Because except this 2, everything will get cancelled. Except the 2 which are circled here, log 10 value is 1. This also will get cancelled. 2.303 by K will get cancelled. Everything will get cancelled except this 2. So it is nothing but 2 by 1. So this is nothing but what T99 is equal to twice of time taken by T9. So hence proved. Suppose if you have not understood this thing, once the class is over, I'll help you out with this. But it's a very simple thing. Just wanted to explain you one more time. See, this is what you have to prove basically. T99 is equal to twice of T90. Correct? We know what is T formula. 2.303 by K log of R0 by R. Yes, this formula already we know. Correct? So 99% completion in the sense, initial concentration always I'll take it as 100, something like that. Since it's 99 here, I'm taking it as 100. Okay, if 99% is completed, what will be the rate of reactants available? It will be only one, right? Correct? So similarly for 90% completion, R0 is 100. But what is the remaining thing? 10 for 90%. I am just substituting this R0 and R value here for both the equations. Then I am dividing T99 by T90. I'll get the answer. It's very simple calculation and not much of a, it's not a huge thing. It's a simple mathematics only we are using here. The complex term here is first order reaction. Those things are complex, but if you just avoid those things, it's very easy for us to do it. So if everyone is done copying it down, let me know. Done. Okay. Okay. 2 students is already done. So I think I'm going to the next topic. One more topic is there. It's not the pseudo first order reaction. It is nothing but the Arrhenius equation. I'll write down here. So I'll write down the equation first so that you guys will be familiar with what it is all about. Okay, so K is equal to A dot, okay, A dot E power minus EA, E subscript A, okay, by RT. So first thing is, what is the purpose of the Arrhenius equation? Correct, purpose. Purpose is nothing but to measure the temperature, of a chemical reaction. Only if I teach you like this, then only you'll be able to remember or recollect. That is the main purpose of Arrhenius equation. Now you might be wondering what are the terms here. Correct. First, let me go with A. This is called the Arrhenius factor. Arrhenius factor that will be given in the question. Okay. And now coming to the EA, activation energy. And R is nothing but universal gas constant. Or I can give it as a gas constant here. Yes. So what is the main purpose of Arrhenius equation? To measure the temperature of a chemical reaction. In the sense, temperature can be determined accurately by using what? Arrhenius equation. Okay, fine. And in entrance or in the board exam, the most probable equation that what we'll be using for this is nothing but I'll write down the important equation here. Okay. And I want to explain the theory because we will do some problems. So there is nothing but log of K2 by K1 is equal to activation energy by 2.303 R by 1 by T1 minus 1 by T2. So this is the equation, correct? We'll be using most probably in the entrance examination. Log of K2 by K1. They may ask you what is activation energy. They may ask you what is T1 or T2. Okay, they can give one unknown variable and they can give the remaining variables, and then they will ask you to find the unknown variable. So only once we just copy down the equation, Arrhenius equation as well as the log K2, this one. The two equations you kindly copy it down. So once you're done, kindly let me know. Okay, fine. The second one is only more important. Log K2 by K1 is equal to EA by 2.303 R by into 1 minus T1 by T2. Okay, so let me stop the sharing. Let's do one problem then. Yes, the decomposition of A into product has a value of K as 4.5 to 10 power 3 at 10 degrees Celsius, and energy of activation is 60 kilojoules. So whenever we find the energy of activation, yes, whenever we find the energy of activation, we can see what we use the Arrhenius equation here, correct? So then let me give you a hint on this. So what is the formula we have to apply in this? Same thing, whatever I wrote last. Log of K2 by K1 is equal to EA by 2.303 R into 1 by T2 minus T1, right? Correct? 1 by T1 minus T2, whatever it is. So I'll just simplify it and write down T2 minus T1 by T1 T2. Okay, I just took the LCM. See, normally it is 1 by T1 minus 1 by T2. So I just took the LCM and wrote it down here. T2 minus T1 by T1 T2. Clear? Now in this question, the decomposition of A into product has a value of K as 4.5 into 10 power 3 per second at 10 degrees Celsius. Correct? So first thing in this is, one of the key point we have to remember in this is, we have to convert Celsius or degrees Celsius to Fahrenheit. So we will add what? Plus 273. So to 10 degrees Celsius, we will add plus 273. Okay. So, and then energy of activation 60 kilojoules. So EA is what? 60 kilojoules. So 60 into 10 power 3. Energy of activation energy. 60 into 10 cube joules. Kilojoules. So into 10 cube. At what temperature would K be 1.5? In the sense, K value initially has got what? 4.5. So K1 value initially is what? 4.5. This one. Now they're asking us at what temperature would K be 1.5. So K2 value is what? K2 value is 1.5 into 10 power 4. K1 value is what? 4.5 into 10 cube. Sorry, one small error from my end. Yeah, it's, I think Prithvi has asked me a valid thing. Yeah, correct. Let me come back to that, Prithvi. 1 second. 1 minute, 1 minute. So Prithvi, your doubt is, I think, yeah, it's I think I made a small mistake here. Correct. So it's not the Fahrenheit thing. Yeah. So to convert degrees Celsius, the Fahrenheit is, I think, 32 degrees Celsius, I think so, if I'm not wrong. Correct. So it is to Kelvin. This is to Kelvin. I have to just erase this thing. Yes, very good. Thank you, Prithvi, for the correction. We have to add plus 273. Correct. So it is basically to Kelvin, we'll add 273. So basically my T1 is what? My T1 is 10 degrees Celsius, that is 283. Clear? Now we have to substitute all of the what things in the given equation. And what is my R value? What is the R value? 8.314. I think everyone knows the R value here. Yes, 8.314. Yes. So kindly substitute and let me know the answers. For this, what is my T2? The thing I have to find here is T2. So let me know T2 value. R is what? 8.314. I'll write down here. R is equal to 8.314. K2 is given 1.5. I written down here. Into 10 power 4. This is my 4, okay? And the other one is 4.5 into 10 cube. That is my K1. So substitute everything and let me know the answer. For T2. Please do it and send me the answer to my WhatsApp.